All right, so we are now going to do an example here. And this example here is going to be example 2.2. In this example, they give you, first of all, I guess I should draw you the circuit here. You've got some voltage, plus or minus, and you've got some current I. Then you've got an impedance Z1 with some current I1, another impedance and an inductance Z2, and this current is I2. And finally, you have a resistor and a capacitor. And we call this impedance Z3 with the current I3. So the question says, this is the complex power balance section, by the way. I should have titled this to say that this is the complex power balance. Complex power balance. Okay. So basically, before we get into example 2.2, I'm going to tell you a little bit about this stuff. So basically, if we want to find the total apparent power, how do you find that? S. So what you do is you find the currents flowing through each of these devices, right? And how do you do that? Well, you take your voltage and you divide it by your impedance. You're going to get some current. Sure. Take that value and take the conjugate of that and multiply that by the voltage. So basically this. And that'll give you your apparent power. So if you want the total apparent power, you take the current flowing through this device, conjugate of that, multiply by voltage, current flowing through this device, conjugate of that, multiply by voltage, add up all those powers, and you'll get apparent power. So let's look at this example here. In this example, 2.2, you'll perfectly understand once you see it. So the voltage is equal to 1200 with an angle of 0 degrees. And Z1 equals to 60 plus J0, and Z2 equals to 6 plus J12. So you want to find current. So you just do 1200 divided by 60. It'll give you 20, right? And what's the angle? 0, right? Because the angle of this is 0 and the angle of this is 0. What is the conjugate of this? It's minus 0. Minus 0 is just 0. So you just do 20 with an angle of 0 multiplied by the voltage 1200, and you should get 24,000, and with an angle of 0, it just means you can say that, oh, it's going to be 24,000. It's only purely real, which means watts. Now we do the same thing. We say 1200. Let me just make sure that it's in the camera here. So you have 1200 divided with an angle of 0, and we divide that by 6 plus J12. Yeah? It's going to give us in rectangular form 40 minus 80J. And now you take the conjugate of that, becomes 40 plus 80J. Yeah? Multiply that with 1200 with an angle of 0, and you should get 40 plus 80I times 1200. And you will get 48,000 plus 96,000 J. If you can't see something, I'm saying it out loud so you can follow along. 48,000 plus 96,000 J. Okay. Next, and this one. What's the units of this one? This one is watts. What's this one? VAR. Yeah. 96,000 is VAR and 48,000 is the watts. Yeah. Because 48,000 is the real one. Okay. Lastly, I don't think I wrote it down, but the Z3, they said that it's gonna be 30 minus 30J. Yeah. So you just do 1200 with angle of 0 divided by 30 minus 30J, and it's going to be 20 plus 20J. Now you just said, okay, conjugate of 20 plus 20j, it means 20 minus 20j. And then we multiply by 1200 with angle of 0, and you're going to get 20 minus 20i times 1200. And if you convert that, it's going to be 24,000 minus 24,000 J. Yeah, this one is in watts, this one is in var. I want total apparent power now. All I got to do is add up all the real component. So it's going to be 24,000 plus 48,000 plus 24,000. It means 24,000 plus 24,000 is 48,000. 48,000 plus 48,000 is going to be 96,000. Yeah, it's a real component. It's a watt. It's watts. Okay, and now you just do the same thing for the imaginary component. It means 96,000 minus 24,000. Now, one thing that you should be very careful of, some calculators, my calculator does this, Casio, basically some calculators, what ends up happening is that when you take a difference, right, and you're in the complex mode, it's gonna take into account the negative, but in terms of the angle, so you won't see it there. So you remember to convert it to standard. So it's 96,000 minus 24,000. It should give you 72,000, right? And that's in var. So 96,000 watts, 72,000 var. Now, last thing I want to mention is that you could have also done this problem in a different way. Let's go back to our circuit. You could have also found the current for each one, added them up, and then say that's the total current multiplied by the voltage, and then you get your apparent power. Or you could have took the voltage, square it, divided by the respective impedances, added those up, and you get the same thing. Yeah. So there's many ways to do this problem. This is the way they did in the textbook, so I just did it like this. Okay, thank you.